Hello, everyone, and welcome to another hardware hacking session. I'm your host, JF Provo, and then we have also Four-Way Handshake with us. How's it going, Four-Way?
Hey, everyone. I'm good. Good. How are you?
Good, good. I mean, there's lots of stuff that we've been discovering lately, and a lot of changes that also happened within the channel, on our Discord server and YouTube channel, as you can see here. We want to be able to remain independent and all that stuff, and be able to provide you the best sessions that you can get out of the internet without being restricted. So it's very cool. It's a new chapter, and we're really happy to be able to move forward. Yeah. So what do you think about that, Four-Way? Is that exciting?
It's very exciting to me. It's been a huge week for us. So a lot of rebranding and kind of a slight change in direction, but I think we're going in the right place right now.
Oh,
So.
I don't think I know we are. I know we are. That's for sure. I know we are.
Yeah.
That's I think this is the best thing for us to be able to actually achieve this, because we're going to be able to move quite a nice way. Being able to do those hacking sessions is going to be like hardware hacking session is going to be a blast, because obviously not every brand or every we can call it, let's say, Try Hack Me, Hack the Box, Immersive Labs, they're not offering the same type of things, right? So now we're going to get to be able to hack a little camera here. I'd say TP-Link C200. This is something that's going to be very exciting for sure. But first off, I have to say a little bit about, like, let's say especially my experience. I'm going to talk about myself, probably not about you, Four-Way, but I am brand new to hardware hacking. I have done other type of hacking, let's say Linux and the likes, but hardware is a lot different in that space, right? So this is going to be very interesting. Again, I'm new, I'm learning. So I'm showing you some of the best thing that you can do to be able to get better. What's basically your skill set over here in hardware hacking, or maybe some of your background you can share with some of the folks that we have here, Four-Way?
Yeah, for sure. So I used to be in electrical engineering. So I've built several devices, designed a few boards. I'm one of those people that I can look at a board and know how it works. For the most part. And what I don't know, I usually have the skills to go and figure out by reading data sheets, things like that. A lot of my skills on actual board design come from my activities as a hobbyist. So whenever I've wanted to build something, I will buy the parts and try to figure out how to design it and then build the thing. So I'm not new to splicing into a serial port and communicating on the chip level. It's been a hobby for a long time. So I'm just over the moon to be able to do this on a stream with you right now.
Yeah, it's so different.
Yeah.
It's good. The same thing as well for me is to have you on this live stream is extremely important to be able to guide me in certain areas. However, if we've known about the other one that I have right here on the back, the other, like the router that we've been hacking lately, but we decided to put it here on the side so we can move onto some other stuff, so we can master one part, which is UART shell. In this case, we're going to try something else. At the end of the day, having you around is very key. But at the same time, I like to push stuff a little bit faster. So, well, the only one that's going to be paying here is me.
Well, then I'm glad it's your hands that are going to get shocked, not mine.
There we go. Yeah, that's exactly what's going on. That's good. That's good. And if there's any fire here, yeah, it's me that's going to have to pay for that as well. So it's all about having fun, experience, and then trying to move forward. Okay, so to give you some preface a little bit, I just want to make sure that everyone knows that we are going to follow, like, and again, like, because I'm new, I need to follow some guidelines from people that are more versatile in that space. And similarly to what I've done with TP-Link, we are going to follow a guy like this guy here, Matt Brown. So I am going to share his YouTube. Maybe I should share the whole thing here, is YouTube stuff directly, so you can actually go check him out, right? And I highly recommend that you subscribe to him. There's a lot of great content that he has been putting out there. So I just want to make sure that he gets the prop for the great work he's been doing lately. Hopefully it's going to show up properly. I hope so. Yeah, I think it's fine. So if you have any issues accessing the link, you let me know, and then I'll try to figure out a different way to attach it to you, and then you can check it out. This is a 2 video parts. Basically, part one is trying to figure it out what's that camera, and then the second part, there's something you didn't know that some of the people in his Discord server, and again, you can join his Discord server there, it is going to tell him, and then he realizes that he's able to get a little bit faster or a little bit further. Sorry. So again, this is all coming down from those videos. So again, I highly recommend you that you check it out. And then eventually we are also going to take a look at this. So we are like, if I go scroll down a little bit more, sorry. There we go. So that's the page where it's very interesting that he's actually going to take a look. And the thing,
Oh, sure.
like he's talking about shorting those 2 pins, which he tried, but it did not work, right? So what he had to do is data out and then go into ground. So out on the second auto negotiation, he does it. He shorts the pins together, and then at that point, that he's able to get a shell, right? Like an actual shell. So we are going to go down the path and see how it goes, and hopefully we're going to be very successful. I see here, does he has a fireplace in Tech Labs? That's very cozy. Yeah, I got a fireplace just right next here. So
it's important to be cozy.
Yeah,
very
that's
important.
good. Exactly. Oh, there's a couple things moving here. Sorry, my screen for some reason moved again. That happens sometimes. I'm not too sure why. It looks like it's my Mac doing that once in a while. Okay, good. Sounds good. So what I'm going to do is I'm going to change to the top-down camera over here, and then we're going to be able to check it out a little bit more, and hopefully we are going to be able to do something very cool. So if I come here and then I change this, put this here. Cool. Do I need to up the? You guys see it correctly? I think it's dark a little bit, right?
It's a little dark, but
Yeah,
that's
it's a little
all.
dark. I can probably try to up the. Yeah, give me a second.
Yeah, so what we have in front of us, this is kind of the mid-consumer grade surveillance camera that you might set up. It has a whole pan tilt assembly in it, so that camera can move around a little. I don't think we're going to be playing with the motors at all. We just want to be able to interface with it, right?
Yeah, that's exactly right. I'm going to paste also, this is a Amazon paid link, if you want to, into the chat. Thank you, Preston, for confirming that it's much better. It's just about ISO that I need to up a little bit. So I'm going to paste the link over here. If you don't want to click on the link, obviously this one is to support us, so you don't have to. I think it's in the description as well, the TP-Link C200. You can check it out on Amazon and then purchase it. It's about $30, right? So super easy to purchase and does not cost anything pretty much. So it makes it a little bit easier for us to be able to navigate and take this along with us. All right, so some of the tools that I'm going to be using over the course of the stream here, we have here our USB key, we can call it, kind of, right? Where we are going to be able to do the interface with our Kali machine and output the Kali, the UART shell directly. And we're going to be able to see exactly what's going on there. And those pins here, or those cables here, are going to be connected with these type of pins here. Sorry, my camera is upside down, so this is something that maybe I should have done like this. It would have sounded better.
Who's to say it's not hanging from the ceiling, JF? That's a normal thing to do, right?
Yeah. I need to change that camera side. I had another camera last time, and you ought to think, well, it worked well. I was able to reverse it. However, it's a webcam, and my daughter needed it, so I gave it back to her. So either way, this is basically the stuff we're going to use over here. If I bring this up a little bit closer and take just one little pin. So basically speaking, while it's not these cables, maybe I should have, this cable here. I am going to put it in there, basically, right? And we can see potentially a little like grabber or hooks or something like that that's going to get onto the pin. And that's exactly how it's going to go on our device. All right, so good to go. So from this point on, what we're going to do is trying to figure out a way to open this up. I completely forgot. I should have brought one of my tools to be able to open this up. Worst case now, if it breaks, it does not matter too much to me. So this is good.
Do you have a little screwdriver or a knife or something?
Yeah. I got something right behind
Okay,
me. I
cool.
just need to go around.
I have an old putty knife that I use for exactly this, just for popping chassis.
I got a bigger knife
Oh.
for big boys. That's interesting enough. Like I think I was like about 13 years old when I got this knife. So hopefully, I'm not going to open up myself with this, and we're gonna try to see how deep we can get. This is exactly the place where he got in. So we're gonna try to see if I can get in there.
So does that have a microphone on the back, or do we figure that's for ventilation? I guess we'll see in a second, but
Yeah,
that's kind of cool.
I'm gonna assume this is probably. Oh, there we go. I got it.
Very good.
This is probably a speaker.
Now, hold on. One thing right now, as we're popping the chassis, is try to open it up the whole way around before you move any part of it too much, because we don't know if there's any wires soldered internally that don't have very much play to them. Exactly. Yeah. So cool.
So we're good to go with this.
Yeah.
Now we have this other part. We have, like you said, we have to go smooth because we could get tricked into breaking it. Oh, I think there is a little screw here.
Why don't you take the screw off the mounting gimbal there? Yeah, nice.
There we go. And everything comes apart. Put the screw over here.
And yeah, that looks like it could be a microphone.
It is possible.
Let's see.
I think it's more like kind of a speaker. I'm going to pop it out in a second. But yeah, it's hard to tell. I'm just going to try to be gentle with it, because obviously when Matt Brown tried to take it off, he kind of ripped off the whole thing here. And I'm not too sure if this one is extremely important. So that's something I just need to be careful about, so we don't break it. Just jiggle it. There we go.
And what's that hooked up to?
Succeeded.
What's the other end of that JST connector that you just pulled out?
I don't see it. It's on the other side. It's in there.
Okay.
So we're going to see it later, a little bit later, I think. Am I able to remove that? It's going to probably be a little bit later. Say again?
I mean, I see two mounting tabs on the exterior, and then you could just push it out by the shaft.
Yeah, probably.
But you probably want to just disconnect the port right off the motor first.
Yeah, I'm going to do that in a second. I want to take off those cable. That thing there, it's annoying. It's like kind of stuck. We can probably call it epoxy or something like that.
Yeah.
And I don't want to break the connector. So that's the thing. So I see that we have a few people in our chat. So I hope you are doing well. Thank you very much for joining us. It's very appreciated that you guys are able to be a part of this journey with us. Again, this is trying to remove, I don't know if you can see it well, but it's kind of like glued in, and I don't want to break the thing. Maybe that's probably not safe to use a knife for that.
If I had to guess, it's a point of weatherproofing. So they put kind of an epoxy glob on it to reduce oxidation for being in a humid environment.
That's interesting.
Yeah.
That's interesting. Okay, so thank you for the information. That's something I don't think I would have known. I thought that maybe it was for like making sure it does not move or something like that, and it stays there.
You know, if it was just for that, then what we probably would have seen is another JST terminal, just like the one that you pulled out initially with the black and red wire. But okay. I would guess that it's for more than that, because you know, maybe some wires that are a little more sensitive to oxidation.
Yeah. All right, this one is coming along. It like when you touch it, it's almost like, yes, an epoxy potentially, but epoxy, I thought it was a little bit harder than this, like coming in like stuck.
Maybe epoxy. Let's just call it goop. I'm pretty sure that's the technical term.
Yeah. Oh, no. Fuck. Sorry.
Okay. So let's see the bottom of the port there.
Yeah. So this one came apart. That's something that we may have to take a look at. I'm not too sure exactly what it is. So,
and let's see the bottom of the goop to see what's separated. So
it doesn't look like we remove any pads. So I think we're going to be fine to be able to solder it back in.
That's right. The board looks fine, and it looks like you pulled off the whole connector.
Yeah,
which is cool. That's fine. Whatever. We can deal with that.
well, which is cool. I'm not sure if it's cool, but still,
it's fine. It's fine.
yeah. So
worst case scenario, we just hold that thing in place and solder it right back on. So
that's exactly correct. Yeah. That's probably what we're going to do later on if we feel that we need it. But you know what? I'm probably not going to give it a try right away.
Okay. Can we open up the bottom housing too, so we can slip these wires through and see what the other end of it is connected to? Because if I had to guess, I'm seeing the right amount of wires for possibly a network connection.
Maybe I don't know. Okay, let me just try to take off the speaker, which we talked about a little bit earlier. Then after that, I'll get to it.
That can probably stay there if you, unless you really want the.
I don't really need it. It's a question you kind of asked a little bit earlier.
What ports does this thing have on the outside?
It's
so
only
got a power plug right there.
Yeah, that's it. Okay. There's nothing else.
All right.
Am I going to be able to pry it out? I don't know. Let's see. Oh, there we go.
Decent.
And here we have.
Sure.
Oh,
okay. So you know what that was? That was a servo connector. So
what?
That was a servo connector. So when you have a stepper motor, like what's in front of you, it requires a few different wires. So you pass a signal to it saying, like wire 1, wire 2, wire 1, wire 2, and then it'll take tiny little steps at like 2-degree increments or something like that.
Oh, okay.
You just kind of repeat that instruction. It's how a lot of robotics works. Where that motor in front of you will only ever move in tiny little increments, but it keeps it from moving too far or moving not enough.
So probably something we don't really care at this point.
That's right. Exactly. We don't care about it. I'm pretty sure we disconnected something that doesn't matter that much.
Okay, good. So this is good. We're going to be able to probably give it a try without too much issues in this case. So we're good. Can I remove this one? I don't really need. Oh, I guess I can. I was about to say I don't really need to remove it, but it seems like it's going to be easy to take off in this case. All right.
And that's the power plug, right?
Yeah.
Cool.
There we go.
Now, if it were me, I'd be scrapping that part and putting it in a bag because those are weirdly expensive.
Are these ones?
Yeah, those little barrel plugs. Yeah,
that's interesting. Give me a second. My hands are. I don't know if you can see it, but there's like grease. So let's take this off for a second, so it doesn't feel like gross or anything like that. All right, sounds good. So let's move this away a little bit over here, so they're not in the middle of everything. All right, so this one here, we can, as you mentioned, probably just like push the motor or something like that, and see if we
get the tabs and then push the shaft on the motor. So the shaft on the motor, if you want it, if you're worried about breaking the motor.
No, I just need it on the other side. There was screws. I didn't realize. So it's just easy to remove them. There we go. Almost done with one. If we don't need it, we take it off. And that's going to be much easier to be able to remove that board afterwards.
Cool.
All right. And everything.
Yeah, those are fun motors to keep in your little bag of tricks if you're into that type of thing. I once did a sun tracking solar panel, and it generated just barely more power than it needed to move itself.
That's good. That's good.
And I use motors just like that for it.
Maybe that's something we could have as a project eventually. Could get on the side, and we could have a Malvik security product that, I don't know, it could be interesting.
Oh yeah.
Just for the sake of it. All right, that's good. Now we are going to remove that board. Remove this screw. Oh, they're tight in there. Okay. To be honest, for most people that are watching us, I don't really care about that thing. So those screw or if anything breaks, it's not too bad, right? In a case where you have to do it and you're actually doing a job, I would assume that you'd be more careful about where those screws are going and what you're actually achieving here, right? So
It's rare that you get a job to just take things apart and destroy them. It's a lot more common that you're trying to fix something, right?
yeah, and to be honest, like right now, to me, it's fine again because this is a project, and at $30, it's easy enough to say, "Oh, look, I'm learning for $30." All right, it's almost out. Do I have all the screws? I do believe I have all of them.
Now, if I was looking at this board and I saw any large capacitors on it, at this point, I'd be saying, "Hey, Jeff, go attach your ESD strap to your wrist." But I'm not seeing any big parts on this thing, so we're probably good to go. I hope you're not wearing wool socks and dragging them on a carpet or anything, but I think you're good.
I should be good. I never plugged it in, so if there's current in there, it's because they plugged it in a while ago. That's what I would
Yep.
assume. And
Cool. So
we have
why
the
don't we
board.
take a little tour around this board before we proceed?
Yeah, it won't be too long. I'm just gonna disconnect this thing.
Oh, we don't want to keep the camera on? Why not, right?
Well, when
Okay.
Madron was actually doing it, was doing it without it, so should be not bad. The only thing he was keeping it was what this motor, I believe. That's the only thing he was keeping on because there's power on it, right? I think that's the only thing he was keeping on this one. Probably on the back, and it looks like it's probably this one, right? And then that's power he needs only in this case.
Yeah, sure. Yeah, sounds good.
So because we're only going to interface with the shell, and then eventually, if we need to, we are going to change it a little bit, right? So,
Yep.
All right, sounds good. So right now, it's not super close. There we go. I'm gonna need to get a better camera to do that eventually. But which chip are we interested in? So the main chip that we are, or at least one of the main chip we are interested in, is this one, right? This one is basically the one that has the memory on it. That's going to be good. And then I think the other chip is it this guy?
That looks right.
Is it this guy? So let me see. That's a T23. That's what it says.
I'm sure it's longer than that, right?
Those things are so small.
Yeah, I know. Yeah.
It doesn't look like that when when you watch a video that he's actually doing.
Here, I'm gonna show something that I have. I got it ages ago, so we're not actually gonna put an affiliate link on this. Hi. Yeah, so this is
There you are.
What's up? It's a pretty old school little microscope that you can attach to your cell phone. So it works obviously best with single lens cameras, so like on a cheap phone or on the rear facing camera. But you just clip this right onto your phone and you've got actually a half decent microscope to use. I think this does, yeah, actually it does 50x, 60x magnification.
Oh, that's nice.
And it has its own little light source on it. So this thing's, it's pretty cool. And it was dirt cheap even like 10 years ago when I got it. It's like $10. So if you're taking apart boards and you're trying to straining yourself to read part numbers off chips, might be the purchase for you.
Yeah, take a look. That's quite good.
That's really good.
Yeah, I mean, like you guys don't see it as good as me, probably.
Can you snap a photo of just it's the bottom line that we need, right below where it says T23.
Yeah, there you go.
Cool.
I got one. Can I
All right, man.
make it even closer?
And if you read that out, I will put it in
Yeah, I can read it right now.
Discord channel. Yeah,
That's a
and
different
for
chip.
folks
If
that
that's
are
the one,
tuning
that's a
in,
different chip than the one Matt Brown had in his camera. So we
okay,
might have to play a little bit around.
right.
So it's a T23,
Yep.
and then I can read the bottom line,
Yes,
which
please.
is 4710912038611 Alpha 20 dash November.
Okay, thanks.
There you go. So that's going to be interesting. Wondering how we're going to be able to do with this. I'm quite sure if I go with what we had from Matt Brown in his video. Let's go take a look. If I can see here. Oh, you guys are not seeing it. There we go. Let's take a look here. So you can see what I'm trying to take a look at. Okay, so that's the short he's doing. Maybe we need to go to the other video before.
Okay, you do that. I'm going to try to look up a data sheet for us.
Yeah, because that's the data sheet he was using, and he had to connect to those pins over here. And the thing is, right now I'm looking at the 2 pins. So it's probably the same. It's just like it's so small that that's going to be interesting. Do I have my stand for my phone? No, I don't have my stand here. I don't think. Oh, maybe. Hold on.
So for anyone that's following along here, what I'm doing on my end, trying to look up data sheets, is I just took that part number and I'm going to pop that into a search engine in quotation marks, see if I get anything. If not, I'm going to shorten it from probably the back end and try to shorten it all the way to the front few letters and just keep searching and searching until I hopefully find something. I'll be honest, that's kind of a weird part number, but we'll keep trying.
Yeah, I don't know if that's going to work. My thing, what I'm trying to do, it's a bit random. All right, let's see. Let's move it down. Let's put some weight over here. Like, that's what you got to do, right? If you don't have all the tools you need, trying to figure it out how to get it done. Right? 4-way.
Oh, of course.
All right. This is something that I've seen some people using cardboard to keep their camera aligned, which is great.
Yeah, we won't say who.
No, should not say who.
Okay.
All right. So I don't know if I can get it done. Oh, I need my little hands. Hold on. Might be helpful for this. Give me a second. I need to bring something over here, maybe. All right, let's try with this thing. So I have
I'm getting nothing off that part number.
No,
that's rough. Yeah.
Well, you know what? Let's assume it's going to be the same thing as the other one.
Okay.
And then hopefully it works out. Because obviously, if you're not getting anything, which is interesting, you can see here on the board right now. I'm just right over top of it, and we can see that's the SSC333, right? And that's what's the name of it?
IP camera SoC processor.
Yeah. Q-Star. There you go. The name of the company of the chip he has is a Q-Star. Okay.
Q-Star. Okay.
Yeah.
See okay, yeah, sounds good.
Yeah. So as you can see, we're trying as much as possible to play around with what we have, right? That's not always going to be easy enough for everyone to have all the tools required to make it happen. So you find ways to get it done. That's exactly what we are going to try to do. Okay. So now I'm seeing a little bit closer. The thing is, I need to know if I'm going to be able to hook on to one of those things and make it work. I think I need to. Yeah, maybe not. Maybe that's a little bit stupid to do that. It's too close. The phone is too close to make it work. I was hoping that it'd be a little bit easier than this. Okay, that doesn't work.
You know what? I am getting hits just for the Ingenic T23, so maybe that was all we needed.
Okay. Are you getting
I've got a
something
data sheet
similar?
here. Still trying to figure it out.
Okay.
I haven't found a data sheet yet, just actually a few news articles on it.
Okay. In the meantime, I'm going to try to hook it onto one of those legs. And hopefully we can make it work. It might be too small. That might not work.
Okay, so yeah, this is definitely it's fulfilling the right function for a chip. So it's an image signal processor. It has a serial port. Sorry, this isn't Chinese, so it's a little hard. But like you said, we do the best with what we've got, right?
Yeah, and it seems that it's not going to actually work. That thing here is just a little bit too big, and there's two different things. It's either we put a pin on it and it stays there, which I don't have.
That is so
Obviously, what he
difficult.
used, it's like the probes that we can see here on the. Well,
Yep.
you guys are not seeing it right now, but you can see here those little probes that he has. That's exactly what we need to be able to get it done.
So,
and
dumb
go ahead.
question, JF. Is there, if you follow the PCB trace for that wire, does it end up at something bigger that we could hook into? Because, you know, a wire is a wire, whether or not it's on a board. Does it lead to a chip that we could attach to its leg
Oh,
instead?
maybe.
Worth checking.
From the top, it seems that it's like a little circle. Maybe if I go and take a look down.
Let's make it big.
So it's right there. And that's the thing, right? I think that's what you're saying. Maybe at the bottom we could even hook it up.
Maybe, yeah. If you think it's a trace that goes through, yeah. Not all the wires are going to go through the board.
No, you're right.
No, I meant like if you can visually follow the wire from what you're trying to hook into, does it lead to another chip?
No.
So if it's a UART connection that you're trying to connect to, obviously it goes to another chip, right? So can we get the probes onto the other chip more easily?
Yeah, I don't see.
So there's zero chance we're going to be able to connect to that QFP chip, that big square guy with 64 pins. No way. It's way too fine. I think it uses like 0.1 millimeter pitch or something. It's just too tiny.
Yeah, I thought I could use the other thing, the other probe, but it seems that it's not working at all. Exactly.
Okay, sounds good.
So yeah, like you said, it's way too tiny. It'd be feasible if we had basically those little probes where you can just like let it stick there and then stay there, right? But this one does not do it. Is there anything else we could use to make it work? And that's what I'm wondering here. Maybe we could use those little hands and then just put that cable on top of it.
I don't think so. It's not going to work. No, it's going to be too bouncy.
Well, that's for sure. It's going to be bouncy.
So how you do this, just saying like in a lab, if you had like the best equipment, is you'd have a little thing to clamp the board into to keep it nice and secure and steady. And then you'd have, you know, 2 or 4 or 6 different probes that you can move into place by turning screws. So it's like super, super accurate and precise. And usually each of those screws has, you know, a few degrees of freedom on it. So you can move it forward or backwards. You can move it side to side to change the angle, or you can raise and lower it. And you just kind of put a little bit of compression on the pin by tightening down one of those set screws. But that's not what we're doing here.
Yeah,
we're
we
gonna do it live.
don't have the same budget either right now. But that's something that I've been looking at them, but they're like super expensive.
They are, yeah.
Those little probes there that he's actually using here on the board. Yeah, super expensive. So okay, how could we get actually this done? Because the thing is, we don't want to short, we don't want to interconnect them. Let me see. I'm curious to see. I know you said it's not going to be feasible, but I'm very curious to see if I could get it done regardless. It's
Sure.
always the mindset of, especially in Canadian Armed Forces, you work with nothing and you're trying to figure it out. How can you get it done with no budget whatsoever?
So look, if you're doing this, what's holding the board right now? Is it in the helping hands?
There's I know I need to move it.
It's just off camera. Yeah, that's all. Okay, so it's in the big clamp, which is pretty good, right?
Yeah.
We want it so that only has a little bit of bounce to it if we're doing what we're doing, right?
Yeah, exactly. So I think like that is not too bad.
So my next thing is like, this is going to sound really janky, but find a way to hang tiny little weights from your helping hands arms. Okay.
Yeah.
So that way you can put in, just a few newtons of force, like just nothing, not even like a tenth of a pound. Like if you were to find a way to hang an eraser or a couple of coins or something, just enough to push the wire onto the board and have it a little bit more secure than having it floating.
The big issue I have with this is it seems that it's potentially even too big, and they might touch themselves or touch each other.
That's what I was saying about wire pitch is that right now you're dealing with pins that are 1/4 of a millimeter across. And you're trying to connect to something that I think is 1/10 of a millimeter across.
Correct.
So there's just physically no way, unless you were to like maybe take one of your pins and go and like sharpen it on something.
Yeah, or put even a piece of tape is going to be too thick at that point, right?
Oh, to separate it from the adjacent pin? Yeah. That's a solid idea. No, I like it, but
because if I'm able to put it here, put a little weight on it, like you said, to keep it like that, might be the solution to make it work. At that point, that's so close. So close.
I love that little clamp thing just moved, and it completely stole the focus of the camera.
Yeah. Talking about that?
Yeah, that little guy.
Yeah, it's not okay.
Literally a wrench in the works.
Yeah. Okay. Hold on. See, we'll fix this.
Now your tiny little grabber hook. Does it seem like it's the same wire pitch as the chip we're trying to connect
to? Say again?
Your hook probes.
Yeah.
Is the hook part the same wire pitch as does it have the same thickness of wire when you extend the little hook thing as the chip?
It seems to be having an issue trying to get through. And if I can get one of those hook again, oh, there it is. Let's move this one away a little bit. If I try to do this, because right now it should be a little bit easier to get it done.
Okay. Oh, you let me know when you're there, because I'm gonna look at the data sheet for a second. You know which pins we're going for, right?
Yeah, we're like hold on. I turned it a little bit, so that's the reason why it's off now.
Ah, shit. So what I was really hoping was that the pins we're going for would be... Oh, actually, there's 2 UART ports on this chip, right?
Yeah.
Presumably, if we're even looking at the right data sheet. There's 2 UART ports, and one of the ports is on the corner of the chip. So that gives us a lot of extra wiggle room.
You think we can
you
take
might
one
be onto
and
something. I think you can try doing that whole like using your helping hands and pushing the probes into place. It might work.
Yeah, I'm
if
wondering.
You were to do that, would you be on top of any other wires? I can't quite see the board closely enough to tell, but if you could work the pins in from the corner, you know, it allows you to press against them from the side, which might make all the difference.
The other thing too that I'm wondering is those pads over here, right? It seems that on his board they're a little bit different, so I don't know if they could be the UART shell. I think
I
on
see some
his it was not.
silk screen on there. Wait, what are they labeled as?
It says TP4, TP3, and then TP1, TP2. So it's hard to tell if that's something meaningful, to be honest. Either way, okay. So I got the connection here. I'm just going to put it back on top. Oh. Is that all metal? Yeah, it's probably not good to have metal on metal, right? If I leave it there.
No, a great workaround is just to get a couple of layers of electrical tape, which has a bit of squishiness to it. And use that over top of the grabber.
A what?
Oh, you know, electrical tape, just regular black electrical tape. Use that as a kind of a gasket between the clamp and the board.
Yeah. This is what I am going to put there.
Super.
As long as I don't cut myself, we're good. All right. That should be fine for this one. And then let's do another one for the top part.
If you can, do 2 layers.
You think that's going to make a big difference in between the...
Yeah, it's double the squishiness.
Well, it's all about the squishiness. All right. Let's put this here.
Cool.
See how it will.
Right, let me check the Discord really quick.
Yeah, I didn't check.
For anyone on YouTube, anyone on Twitch, when we're not live streaming our hardware hacking, we're almost always on Discord. So come and join us at the link that you see at the bottom, and we would love to have you.
Yeah, we don't concentrate ourselves only on hardware hacking. We do a bunch of different things. Could be hack the box, could be sense challenges, could be even like what's it called again? Oh, maybe not over there. I should put it. I forgot the name of it.
Try hack.
Try hack me. Yep.
Yeah.
Okay, so that's. Let's put it this way. I think that's probably going to be better because if I need to get access to this part for some reason, at least I don't have to restructure the whole thing.
Yep.
I need to
Sounds good. You know those little cones with magnets on the back?
Cones with magnets on the back?
Yeah, it was part of your that cool kit that you got with that silicone mat. You know, there was these little like bullets, magnetic bullets.
Yeah.
And so they're for going on into the holes where the mounting screws would be. Yeah, those guys.
Yeah.
You know, that would give you a really nice solid.
Oh, I guess I could do that too.
You know, it all depends on your camera. You know better than anyone else. So.
Well, I mean, like the camera is the one that's a little bit tricky right now because obviously I need to kind of change or lower down the camera a little bit to make it better. Am I going to be able to make it work? Sounds like potentially.
See, my reasoning here is that like when you put it against a solid backing, like with using those little cones, then you only have one degree of freedom for each pin on what is like, you know, squishy, right?
Yep.
What's going to have a little bit of give to it. And that's the best thing because then we can just hang a couple of weights, you know, one for each probe. And we've completely accounted for any give, any play in the connection. That might make all the difference if we're trying to connect to a serial port with as little noise as possible.
All right. So it's probably not too bad. A little bit wobbly over here, but I should not need to get access to that part. So it should be good to go. Let's move this away in the meantime. And then now to the hard part. but I need to put it back into the frame. I should have put it right in the frame. There we go.
Okay, not too bad. Pretty painless. Yeah, cool. This is exactly what I hoped you would do. Perfect.
There, it's off just by a little bit. So not the easiest thing to kind of center. Oh, okay. I think I almost got it. Okay, that's not too bad. There we go. I think we got somebody that's did I think we got somebody on Discord that actually wrote something.
Oh, really?
Or no, that's a different one. Okay, never mind. I thought it was someone. I heard a message, so I was wondering. I thought it was someone, but never mind. I don't. Okay, so now we have this. Can we actually get it done? This is a big question. If we're not able to get it done, obviously, I mean, we can go with the plan B that you offered, and then hopefully we can get the stream onto the right path. So I don't want to put my head over top of the camera. So basically speaking right now, oh,
Yeah.
no, that's too wobbly over there.
Is it? Oh,
yeah.
shoot. Okay.
It was a lot more secure with the other thing, unfortunately.
Okay.
It's just like those corner here, right? Too easy.
Oh, wow.
And yeah.
Yeah, all right. I wasn't expecting that.
Because the thing is, if I put it here, like this one, I don't think it's going to make a difference. Yeah. And I need to put pressure over there, and it might just like, it's going to start wobbling. So I need the other thing. I need this guy back.
Oh, I see the problem. Yeah, you've got 3 points of contact, and like
Yeah.
the thing that you're trying to press into is outside the triangle of the 3 points of contact, not inside. I see. Cool.
Yeah. So let's revert back to our other plan to make sure everything's good.
Cool.
Hold on. I'm missing the chat if we're missing something. No, we're good. All right. Good to go. So let's give it a try again once more. And then here we are going to go. I know it's super small, and the way you see it right now from the camera on top, it's almost the same way I see it as well, right? So it makes it a lot harder to be able to do it without a what's called a microscope. And I think this is probably one of those things that I won't have a choice but to buy and then add to the whole thing. So basically right now, I'm just trying to get a hold of the actual pin and make sure that it sticks there. And that's the hard part of what I'm trying to achieve here.
Do you have a weight ready to go to kind of secure it once it is in place?
Don't have one, but I won't have
first.
a choice. Yeah, I won't have a choice to have one there. So how can we do this? I got these things. I can probably put one of these there.
Yeah, I mean, do you have some extra hookup wire or something like that?
Yeah, I got a couple.
You could always just like take some hookup wire and wrap it around, I don't know, coins, an eraser, a little, just any weight, right? Anything will work.
This one should be fine.
Cool.
I can put a second one if I need to, right? Like this to make it heavier. Okay, let's push it down. There we go. No, it moves as I. Okay, so
where's the weight?
Yes, yeah, the weight is not enough. It needs
put the weight right at the end of the arm, just so it's hanging right past the board. Because then it'll have more torque on the arm. Yeah, cool. Just like that. That works. Even just something like a twist tie or something, or hookup wire. Yeah, cool. That's exactly what I wanted. That's great. How's that? Might work.
Almost. Yeah, I think it's there.
Okay, cool.
I think it's touching it.
Yay!
Yeah. Let's check it out.
Is that worthy of a cheer? Here.
Almost. Almost worthy of a cheer. Okay, so let's take a look. Oh my god! Even with that thing, it's hard to tell if I got it in. I think it's on, but the only way to be able to check it out is going to be to test it afterwards. Yeah, but that's one way to do it. Okay, all right. So now let's see if we can get the other one done. What was your suggestion here, Four-Way?
Nothing. Continue as you're doing. I think you're doing a great
But
job.
you
It was
said that
but
we
just
had
do it again.
You said that we had one pin that was good. What about the other pin? I think on the other side you were saying, right?
Yeah.
Were you talking about that?
I mean, I would probably use 2 arms for it. You know, use the other arm and just do the same thing.
On the other,
you're doing a solid job. Yeah.
So you talk about, let's say if I bring the thing in, like, okay, we can see it here. Let's say on the where's my, this one needs to go away. Sorry. So if we bring this in, right now I'm attached to this one. Okay, to this pin that's right there. Are you saying that go with this pin still with the amount of flexibility that we have, or we go towards the end over here? I don't think those 2 pins. For everybody's perspective, if I can, I will bring the copy link, bring it here, paste, and then let's go. All right, so we have at one point there we go. Okay, so we have this pin that we are connected on. We have this pin that we're connected on. You mentioned a little bit earlier there was something interesting potentially about these.
I mean, yeah, exactly. So we're seeing the FUART RX and FUART TX. So I did a Control F and looked through the data sheet there, and that is the fast UART. So I don't know, man. It sounds more promising than the debug UART, but also if it's the debug one, maybe that's going to be closer to getting us a root shell. It's hard to say.
Yeah. And the other thing too with the fast UART, it's probably going to be like not 115 to 100 baud or whatever the case may be, right? So the speed might be a little bit different, which we are not sure exactly what we need to be able to accomplish that. All right, so let's see how we can get this other one achieved. And I need another one. So a little bit not what I was expecting. I was hoping to be able to get this done with those little arms earlier. So it's unfortunate, but hopefully we can make it work.
Since you got one of the kind of hangers working, or one of the weights hanging from the arm, would it be too crazy to put both pins held by one helping hand's arm?
Both pins?
Just kind of, yeah, both pins.
No, I think
I know it's a little weird, but you could just kind of squish a piece of tape between them to space them out just so and put them at the right angle.
Yeah,
you know, we do our best. Yeah.
Yeah, I don't think that's going to be working, to be honest.
Okay.
I think we're a little bit screwed for that part.
Sounds good, man.
Like you can see here, if I need to try to move it a little bit like this.
Yeah.
Like so. And what I'm going to do is I'm going to bring this one closer, right? I think that's That's how I did the other one.
Do you have some hookup wire? Because I don't know about you, but I keep like a few spools of like 22 gauge wire, which is pretty thin. It's about the same
What?
thickness as the jumper wires that you're using right now. You're using male to male jumper wires, right?
Yeah. No, the
But
other ones I have are much bigger, so it's not going to work.
okay, sounds good.
Oh, my bag. Hold on, my bag is stuck to my chair. That's the beauty of live stream. Sometimes stuff happen when you're doing it offline. You don't see these things happening. All right. Yeah, I need tape for sure, because they're going to be connecting to each other. But I am kind of scared that it's probably not going to work, because the thing is, I might touch the other one just a little bit too much, and it's probably going to screw it up regardless. Yeah, I think that's just too bad. And then this guy here.
You know, it's not so bad. We have this video that you've referenced, right?
Yep.
And we have a chip that looks like it's probably doing the same job as the one in the video, right? That's all good. Are there any other chip numbers that we could read from the board to get a better sense of what we need to do?
Potentially. Let me try. If it works, perfect. If it doesn't work, we can check it out. If it doesn't
Sounds
work,
good.
what we're gonna do is, obviously this is just a part one. We can probably just stop there. I'm gonna have to order something that will make sense at that point. Which again, oh, look at that.
Oh,
I don't even need to attach it.
The magnet worked, eh?
Yeah.
Oh, that's wild. That's super cool. Oh no, we lost JF. Or we lost.
Oh, nah, the other part didn't bend at the same time. Gonna remove this for a second. Looks
It's okay. You know, this is probably one of those situations where we need to come back with a little better tooling.
Yeah.
And
Yeah.
sucks, but it's what happens.
Well,
A lot of these things are not a project you want to finish like over a specific weekend. unless you're already super prepared to do what you need to do.
Yeah, if that's your job.
Sometimes you need to order some parts and come back to it, and then order a couple more parts and come back to it. And there's a bit of a try and fail, and hopefully a try and succeed at the end. Yeah, it's cool.
But
what I was saying, Jeff, is like, could we
something.
get a part number for the firmware chip? If you said that there was one chip that you highly suspect is the firmware.
Yeah,
right?
we could probably extract the firmware out of it, and then
let's
just
get the part number so we can pull up the data sheet and take a look at that.
After this, give me just
good, man.
a couple minutes to give it a try with this one, and then see how it goes. I think it's super close of working, and it's probably going to short. But I'm very curious to see if it's going to actually work in this case. I kind of think it's not even touching. Let me see real quick, and if it works, it works. It'd be perfect. Yeah, I'm not able to see. Those little things are extremely important. So yeah, so there's two things we need for next time. This is basically if we go to disk level disk scope, we're gonna need basically pins, right? That we saw with our friend.
Yeah.
Where is he at? Okay, you're there. Oop, that's not the one I want.
You mean like proper like lab probes, like I was talking about, right?
Yeah, well, yes, pretty much. The same thing as this, right? So we can put it
Yeah.
on, right? The same thing as that. I can't remember exactly how he calls that, but we need this and we need a microscope as well. So there's two things that we are missing for a device like this. Again, I thought it, like from a microscope, it looks like it's decent enough that my little pins would have grabbed onto that, but they do not. They're not able to, well, I mean, maybe it's just me not being able to actually achieve it, but that's the little pins that we need to get a hook on, and that's where
That
we
looks like
are
the same
struggling.
size as what you're using. It looks like he's probably working at the same scale as what you're doing.
Yeah, potentially, but I don't see close enough
That's it. Yeah.
from my view. So because of that, that's the problem. And then those little hooks that I currently have, if we take a look over here, yeah, I don't see enough in that area to be able to really like make sense of it. Obviously, like you almost see the same thing as me,
Yeah.
which which is quite hard. So okay, so give me a couple of minutes. I'm going to get a ground as well, and then after that, we're going to be able to keep going with everything else. At least to give it a try, see if it works. If it doesn't work, we are going to extract the firmware, and that's going to be pretty much the end of it until we have other parts or other tools to be able to make it happen.
Okay.
All right. What are we looking at? Okay, so we got this. Now I need this one. I need this one to be hooking on to. Hopefully, it's not going to make any problems. I'm going to try to hook it on there. Oh, that's sharp when you press on it. I'm going to take the black. I'm assuming the black is the one that's good. That should be going there.
I don't think it would matter.
Well, for this cable, yes. Like this cable is going to go directly on my computer.
Oh yeah, of course. Yeah.
That's the one
I thought you meant
about.
the black probe.
No, it's the black cable.
Okay. And that will be your ground, right?
Yeah.
Okay. I'm sure that you could just connect to the ground that's coming out of the power port. Remember that JST connector that had a red wire and a black wire? That would be so much easier to connect to. And honestly, at this point, I would probably just snip that JST connector and expose wires for the ground and the power, because that'll be a really convenient way to splice into the circuit.
So you're talking about this?
Yeah, that little guy. I would probably just cut that off and attach, like solder on new connectors to the end. Something that's a little more conducive of prototyping with it.
Okay. Yeah. Okay.
You know what I mean?
Yeah. I kind of understand what you mean there.
Okay.
But I'm wondering if I could just use something else. Hold on. Trying to see here, because obviously there's that other part that's here, right here, and I was wondering if I could use one thing there, but it seems that I'm not able to. So might not work this way. So that's I thought that maybe the outside here would have been feasible to work. But I may not have a choice to do what you're saying. The thing is, I want to try to avoid soldering if I can. At least for this stream. Could we use, let's say, the back plate of this? Do you think it would work too? I'm not hearing you.
Sorry.
Yeah, there you go.
I said you've got a multimeter. Go check. So just like check the resistance between the backplate of the motor and and whatever you suspect to be the ground pin.
All right, so we're going to put it on the continuity. So should have a little beep when we have continuity right there. And then let's see if that's going to do anything there. So I'm assuming I put it on one on the pin.
There's only 2 pins, so just check them both. Yeah.
There we go.
And honestly, so you've got the barrel plug still, right?
Yep.
That's really easy to connect to. You can
I
just
guess
wrap a wire around the outside of it, and that's your ground. So if you connect it's just the inconvenient thing is that the barrel plug wires, they run through that motor assembly. And so you'd have to hook the motor up to the board again. But regardless, that would be a really easy and like huge way to access the ground.
It doesn't seem to work.
Okay, yeah.
I'm on the ground, so it's not telling me that it's working. If I decide to come here and then, so
yep,
I'm touching it correctly. Okay. So do we have another ground somewhere that seems that, or could be potentially worth?
Yeah, man. So just take that JST connector and plug it back in onto the board. Okay.
All right. Okay, so talking about this one here.
The one that runs through the motor assembly. Yeah, exactly.
Yeah, so I'm going to need to get some elevation right here because otherwise it's going to be putting pressure directly on the rest of the board.
You could tape the motor to the clamp or something too. If that works.
Yeah, true. Let's try it this way for now.
Sounds good.
Since it's right there, and then if it doesn't work, we'll readjust. I should have left it plugged in. I think that would have been much better. Well, it's because I might move the clamps.
Yeah, and exactly. So if you hook them, if you just tape the motor to the clamp or zip tie it or whatever, then it's gonna always be convenient.
Oh, there we go. I think we're good.
Super cool. So now take the barrel plug that's on the other side of the motor assembly.
Yep.
And the ground is the outside. So
yeah, the ground is the outside there. However, the red is on top here. We don't see the outside. It's all plastic.
Oh, okay. You have no way to access it from the
I see the
there's definitely a way you can just pry that apart to access it, but
well, I see here. I'm just removing
do whatever's going to be easiest.
Yeah, I'm removing some tape. Do you see it? Oh, you don't see. Okay. Like
also, I mean, you have the barrel plug that used to go in there, right? From whatever power adapter. So you've got the socket there. You could just take the plug, snip the wire, plug it into that port, into that socket. And then you have an easy way you can access the VCC or whatever the high voltage is, right?
Yep.
Maybe it's, I don't know, it's probably some DC voltage. Cool.
I got it. So if I take this, just making sure that it's actually working.
And what did you connect that to? We couldn't quite see.
It's the on this part.
Yeah.
There is like the ground that's right there. I just removed some of that
perfect, dude.
Oh?
Yeah. I like it.
Yeah, that's basically what I did.
So this is one of those moments where if you had your soldering iron handy, it would have taken under a minute to just snip the red and black wire.
Yeah,
and to attach a new pin on each side.
Yeah, it's behind me. It's just I need to turn it on. I need to get everything ready to go. So I'm going to try to make sure if we can do it as fast as possible to get the audience there what they came in from for. I mean, all right. So we got this. I need to plug in as well those big cables there on top. I'm going to use these ones here. They're quite long. I'm going to use 2 of them. One is going to be connected on this guy.
And hold on. Let's start writing stuff down because you're making a decision that we need to know at this point.
Yeah.
Is that RX or TX that you just connected to?
This one, I mean, I need to take a look at the data sheet, but the first one, which is brown, I connected to the second pin, we can call it, if we go from pin 1.
So is it the one on the same edge as pin 1 or the one not
the
on
opposite,
the same edge as pin 1?
Opposite
it's
edge.
Further.
Yep.
Okay.
So that's the difference.
So then it was TX that you connected to. If it's the
okay, so perfect. So if it's TX, it needs to go into the other guy. So if I plug in my USB like so, oh shit. Okay, I'll plug it in afterwards because otherwise it's going to be a mess to just play around all the time. Okay, so my ground is the second one, which is good. Then I have TX. TX is going to go to the purple cable that's right there, right? The one we just connected on, because we need receive, correct?
Can you point to which corner of the chip the dot is on? Great, good. So that would be
the purple.
That is RX then.
Purple is RX?
Yep, purple is RX.
Okay, so we need to put it on TX on the other side then. TX, which is the third cable, and then blue. So connected to the blue side or the blue one. Then we need the other one to be with receive because the brown one or white, that should be transmit, right?
Yeah.
Okay.
Yeah, right. Let's transmit on the debug UART port. Because remember, we have 2 UART ports.
Yes. Sorry. Yeah, I should have. Yeah. Okay. So purple is. Let me just have that sheet there. I'm just
pen and paper is your friend here.
Okay, there we go. So receive. Okay, I got it in front of me now. So it's going to be much easier this way. Okay, so I have the RX purple goes to TX, which is the second one. Good. And then the other cable, which is right next to it, the green goes to the other one. So, okay, good. So you guys don't see it, but I have the data sheet right in front of me to make sure that I'm doing it properly. Good. That's something that 4-way educated me on. If we want to put it this way.
Educated. I love that term. Yeah.
I got educated. Okay, so now I have the power, right? It's unplugged, as you can see. And what I'm going to do, because we have so many different things that needs to move, I'm just going to plug it in right away, because otherwise it's going to unplug it.
While you've got that out, what voltage is it running at? Because we can read the power adapter directly.
Sure.
Without even taking a measurement, we could just read the sticker.
Well, interestingly enough, I think it's the same one as my other TP-Link, the router. So, okay.
So 9 volt then, right?
I think so. Let me check out 100%. Just gonna take my camera to it because otherwise it's just like it's hard to read. 9 volts, 0.6 amp.
Oh, good.
Yeah. And what about the router that we have? It's 9 volts, 0.6 amp. It's the exact same thing. And I think the current is the same way. So straight line and then dots.
Yep. And so it's DC.
Yeah. And then this one straight line and then dots. So it's the exact same thing. So I'm not going to unpack the other one. It's the exact same type of power.
Great.
Yep. So we don't need 2 in here.
That means we could destroy one of them if we need to do some spicy or something like that.
Okay. So now let's give it a try. Let's give it a try and put it on directly there. Again, we're using the tools that we have at our disposal. We are not professionals, so we are trying to do whatever we can with what we have. And it's a learning curve as well to understand that sometimes you need specific tools to make sure that it works well.
Yeah.
So that thing there is not. I think even those little hooks there, I'm gonna need something else. These hooks are good, but not good for handling things like this.
So I'm gonna take the stream for a second. Let's see. Hey, so if it were me doing the job that JF is doing right now, I've showed you guys, our viewers, a breadboard before, but if you wanted to go even cheaper, something that I would do is just solder wires directly into like a this is called proto board. So it's super cheap. It's just a sheet of plastic with metal traces on it. I've used a box cutter to basically draw a breadboard onto it by cutting the metal. And then you just snap off pieces with pliers. Super cheap. The idea is that you run wires through this, you solder it on one end, and then you've got a really easy and reproducible way that you can connect in a circuit just like JF is doing right now. But on top of that, it allows you to build something a little more permanent, even though it is like circuit specific for just this one board. You can snap off a piece of this costing you 10 cents, right? And have a really reliable way to connect to the rest of the circuit. And all it would take is like 1 minute of soldering. So one of those things where if you have everything on hand, it can be really quick and easy.
All right, so I think I'm going to have to just put a little bit of pressure here. So it's not going to be viable probably to do this, but
Okay.
I guess that's what we're going to have to check out. And then if we were able to get a shell out of that, I don't think we're going to go for the second part and then shorts and do that type of stuff because I don't think it's going to work well.
Sounds good, man.
Right now,
I have one tip for you.
Yeah.
If we're checking how good of a connection we have to the board, right? Using the helping hands, we have pins that are connected onto the board, right? And we're not super sure if we made a good connection or not. One thing we could do is watch the voltage on those pins. Now, of course, I'm going to give this big caveat in that the board would need to be powered on for this to be a useful measurement. But if we watch the voltage on those pins and we do have a solid connection, we'll see a really steady voltage across them. It should be, if we take our multimeter and hook it up to those pins via our little interfacing probes, right?
Yeah.
If we were to measure the voltage on that, we would get either 0, probably 5 volts, or sorry, 0, 3.3 volts, or halfway in between. Okay.
Oh, my battery.
Oh, okay, got it.
That's all right.
I thought that was the short detection.
No. That's my battery in the background. I got a couple of UPS, and there's one of them just having fun right now.
Oh, weird. Huh.
Yeah, that's fine. Nothing is burning yet.
This is the moment where we say, "Oh, Canada, it's a developing nation," right? Yeah.
I mean,
anyway, so you can take a simple measurement to see kind of the integrity of our connection to that pin.
Before plugging it in with this, like the USB I'm talking about.
That's the thing is it before plugging it into the USB TTL converter, but after applying power to the board.
Yep. Yeah.
So it's still following. A slightly risky move.
I'm following.
Cool, man.
So I'm probably going to remove that USB cable. Oh,
yep.
Don't burn, please. Okay. The USB thing is out. So you can see here it's unplugged. That's the part I was talking about.
Yep.
Now ready to plug in and then see how it goes. It's plugged in. Then we are going to check out if we have some sort of interesting thing going on. So I'm going to plug it in here.
Plug in what? You're just off frame, I think.
Sorry, I'm putting on the TX, the probe. Unfortunately, hold on. I might be able to move it.
Probe TX to what though? To your TTL converter or to your multimeter or what?
So I'm just putting here my cable onto the ground. Oh, maybe I should put it there instead. So my ground to ground, right?
Okay, so it's the TTL converter that's right off frame, right?
Yeah, yeah. And then now I'm just trying to take a look here.
That works.
On voltage.
The thing is that little guy's connected to USB, right? Or is it not? To do the thing that I was describing before, you need that USB TTL converter to be disconnected on the USB side. It needs to be a floating wire, electrically. It needs to not actually be hooked up to anything.
Yeah, you're right.
For the measurement that I was describing, you need
so it needs to be connected on the USB?
No, disconnected.
Oh, it's disconnected. See?
Yeah.
That's what I'm talking
Okay,
about.
cool.
Yeah, no.
Got it. Sure.
Yeah, no, it's
Then
already disconnected.
You've done it perfectly.
Yeah. Well, maybe not perfectly. Don't give me too much. You never know. All exploded. All right. So I don't see anything on the first one. Do I see anything?
Let it sample for a bit. I mean, is it a steady 0 volts?
Yeah, it was 0 volts.
Okay, so what measurement setting are you on for the voltage?
I'm on. Oh, hold on.
Kick it as low as possible. If you're measuring 0 volts right now, can you put it into the 100 millivolt range? Okay, so look, you've got that on 600 volts. Bring it all the way down to 200 milli.
Oh, okay. I went the other way around.
Yeah.
All right. I mean, that would make sense.
Then we can get a much finer measurement, right?
Yeah.
Because 200 millivolts, we're actually going to pick up electrical noise from the air, right? When you're testing a circuit like this, if it's coupled at all to just line voltage flowing through your walls, which it will be, you should see a millivolt or so of fluctuation. And that's just because of the way that
this one,
the wires in your wall are going to induce a tiny current in the wires that Jeff is hooking up to.
So this one moves actually.
Great. What's it moving between?
So as I press on them, if I bring this one over here, right? I'm going to take the receive basically of the cable. Okay.
Yeah.
So, and that one on the ground, and then the other one on the receive of the cable.
Sounds good. Answer me this: when you move your hand close to it, does it change?
I don't know. Let's see if I touch it. If I'm touching it, that's what it is, right?
Yeah. Okay.
If I don't touch it,
it's fluctuating a lot.
Hold on. And then here,
so
I'm basically
reading this upside down, but I'm seeing at least 20 millivolt difference.
Now I'm not touching it, right?
Okay. No, I don't mean touching it. I'm saying hover your finger near it.
Oh, near it?
Yeah. Does it cause a fluctuation?
Yeah.
If so, we probably don't have a good connection to the board.
Yeah.
Sorry.
Oh,
I was happy because you got a good measurement, but I'm unhappy because it means our connection sucks. So sorry, man.
Oh, that's all right. That's what I was expecting. I want to give it a try regardless.
Yeah. So we're checking for a floating voltage. Okay. Just, is there a voltage induced through the air? Because if we had a solid connection onto the board, we would see that a lot more steady of a voltage.
So this one, is it because I'm too close? Let's maybe this one here. No.
So that's on a 2 volt range, right? So it's going to detect maximum 2 volts. Yeah. You want it as fine as possible.
Yeah.
That's the point. We want to detect millivolt fluctuations.
Yeah, and the thing is, I don't think we have a good connection. So I think it's time to move on to the other part where we can
Sounds
be
good.
here for a long time.
Yeah.
So in our case, unfortunately, for those that are here or maybe the people that just joined, we can see that when we are learning how things are working, sometimes we are going to realize that we might need extra tools. So in our case, that's exactly what we need to be able to get a UART shell to move through.
That's right. And just like when you're hacking on software, when you're dealing with hardware, it's really, maybe it's extra important to move in small steps and verify what you're doing at each kind of checkpoint between what you're doing. So we made a connection, and at face value, it looked like we had a pretty good connection to the chip right on the corner with those probes. But we verified it using a tool that we had on hand and found that no, the connection probably isn't very good. So it's okay. It's better to know that early on than to try something more complicated and wonder why it's failing.
Yep.
Right?
Yep. All right. So now let's go to step 2. I'm just going to remove that freaking thing. Hopefully I'm not going to rip off that connector. Come on, be friendly, please.
Yeah, exactly. That should do it.
Well, that's what I was trying to do with my hands, but it seems that it's not working well. I'm not pulling on the cables. It's coming out, but okay, you know what? Let's
tug on those
leave
wires
it there
a little bit.
because I'm kind of scared of ripping it off.
What I like to do for that, Jeff, is if you have a really small knife, like a little box cutter or something, I like to wedge it right between the plug and the socket and just kind of rock it back and forth, to separate it.
Well, I was able with my fingernails to get underneath it.
Yeah, sounds
so
good.
That was not too much of an issue. It's the issue that I was applying an amount of force that I was like, I don't want to take a chance to rip it off. So with a knife, it's probably going to do the same thing, and I don't want to take a chance. So I'm just going to leave it there for now, and that's fine.
I meant if you have the knife between the two pieces, the two plastic pieces, you can wedge that safely without ever having to worry that you're going to pull a soldered. Yeah.
Oh, okay. Yeah. So next time, that's probably something I can do. All right. Or maybe like a really fine screwdriver maybe can also work.
Yeah, sure.
Okay. All right. So now we have the actual chip that we were talking about. Let me get this back a bit more into where we are trying to get this done. So this is the actual chip that we want to take a look at and potentially remove the firmware out of it. And then if we succeed, that's perfect. If we don't, I mean, that's going to be the end of the stream for now, eventually. Okay, so.
Do you have part number? Okay, yeah, you're getting it. Sweet.
Yeah,
thanks.
I'm getting there.
I will.
This is the first time we're looking at this chip, so. Yeah. Okay, so it's a XMC. And then the parts number. Are you ready to copy?
Yeah, I'm in Discord right now. You just read it out for me.
Yeah. 25 Quebec Hotel 64. I believe it's Delta Hotel 1 Quebec.
Okay.
Can see. I think this is what it is, right? If we put it this way. No, you don't. Oh, are they reverse? There you go. Should be able to see it. So if anybody's interested into that specific thing. There we go.
Okay, thanks.
So I brought my laptop closer. You guys can. Oh, I'm a little bit bigger than 4 away right now.
What's with that? How did you do that?
Well, it's whatever.
I don't care. It's cool.
Yeah. All right, let's bring it up here.
Okay, so I am getting hit with EN25QH64. So just pulling up the
data sheet.
Yep.
That's good.
And it is Exactly what we're hoping for. It's a memory chip.
Yes.
Great. So, for anyone that's following along, this is basically a flash drive planted into a board, right? It's flash memory. It holds 4 kilobytes.
4 kilobytes. Wow, that's quite small.
That's not much. You
Nope.
can't do much with that.
Nope, exactly.
Maybe I'm reading this wrong.
All right, so this one here, I'm going to need to move it a little bit because my laptop is it's getting closer than what it was in the past, right? So it's already a big plus, but it's a little bit on the side there. So
it is 64 megabytes. So it's probably just big enough to hold their firmware.
All right.
I don't know. So the firmware that we pulled off of the
router.
The router? Yeah. I'll check the size of that. I've got it right here.
Okay.
I'm pretty sure it was only a few megabytes, like 8 megabytes or something.
I cannot recall how much it was. Okay, so this one here, not the preferable way of being able to do that. I'm gonna give it a try regardless. And then we can see if it's gonna work. And my laptop needs to be a bit closer. And I think we're going to be fine this way. Okay, you guys don't really see it right now. If I want to take this, you're going to see here, that's the USB that I attached. Maybe I should have shown it on stream. This is the USB that I attach basically with this ribbon cable. That's right now attached to the, I did wrong. So,
backwards again?
Hold on. I need to check where the dot is. So
yeah. Make sure you do.
Yeah.
And yeah, so I just checked my files, and it's 7.4 megabytes for the whole Squash FS on the router. So we're expecting something probably not much bigger on this. It's going to have to, at the end of the day, run a pretty similar operating system behind that chip, right?
Yeah, probably, yeah. Hold on, I need to find the chip again. Okay, so the way that the chip is, I just want to make sure I have the right one. No, that's not right.
Are you gonna just pull it over terminal again?
Yeah, I'm gonna put it there in a second. Just want to get it on top.
Yeah.
And I think I got a good connection.
Okay.
I'll move it in a second. Entering my password. And then now let's move on to the other one.
I wonder if a lot of these flash memory chips are 8-pin SOICs like that. If so, I mean, that's maybe a more useful tool than I thought it would be even.
Oh, that's okay. Good. I thought it was limited by the screen space. I was like, no. Okay, so as you can see, we're back into the same stuff that we were doing last time. So I'm just going to take this down. Here,
we're done with
what's interesting
for now, right?
Say again?
We're done with Pulse View, right?
Yeah. I just minimized it. I don't think we're going to need it later on. Okay, so TP-Link. This one we need to probably create our own stuff. I need to adjust this. There we go. It's going to be a little bit easier to type in. So make dir, make fur, not make fur, make dir. And then we're going to call it TP-Link.
Yeah.
Camera. I'm a little bit off, so it's kind of awkward the way I write camera. CD TP camera. And then here we are going to use the flash ROM. It's the almost the exact same thing that we're going to use. We're going to have to change this one. I don't think it's the same one.
I bet you it's just a different size. Hey, look at that. It's only the last few digits that are different.
For what?
That's wild. For the chip number that you just.
Oh, okay. They're probably using the same thing over and over and over.
EN
There you go.
25QH64. So yeah.
25QH64.
Yeah. That's what you just told me.
Okay. And was it B or was it something else?
No, it was something else. Hold on.
I got it here. It was QH1Q.
It was DH1Q. Unless maybe I wrote it down wrong or you read it wrong.
It's possibly it's D.
I don't think
so
it
hard.
matters.
Yeah.
I don't think it's going to be the same family of chip. So, like even just on this one data sheet, I'm seeing the chip in
D.
4 different form factors. And usually at the end of a data sheet, let me just check right now, but they give you the specific part numbers based on which form factor it is. But the first like 90% of the part number is all the same.
Okay. So it's my phone just moved it. So the way I'm reading it is 25QH64D.
Okay.
Are we supposed to have the EN before?
Yeah, that's usually the company.
Okay.
So I bet you EN stands for Eon.
This one is XMC, so would be the same thing?
I guess so.
Okay. All right. Let's give it a try. So EN25QH 64 DH1Q 64 DH1Q. There we go.
Yeah, that's what you read out to me. And
Yeah,
then to get, I bet you that number you have there is too specific. So we'll end up trimming a couple letters off the end. We'll see. Try it out.
Okay. So this one here, let's try exactly what you just said. Let's remove what, 2 characters or just one at a time?
Why don't you run what it's saying, flash-rom-l, and just grep through the output for EN25QH. Because then we'll get the whole, all of the chips of this family that are supported.
Oh, okay. So this, but we are going to do -L like this and then C.
I think,
or remove everything.
Only give it -L. Yeah, remove everything. And now grep for EN 25QH. Make sure to grep -I too.
Yeah. -I EN
25QH. Yeah. Great.
So
That's exactly what I was looking for. So just end it at 6.4 this time.
Yeah, I think you're right. All right.
Yeah, exactly. Did your thing pop off? Your port?
Say again?
Did your port pop off? Is the clamp still connected?
Yeah, it's still connected. The other thing too is might be me that reversed the other thing. So give me a second.
Okay.
Just gonna remove, well, not remove, but move it around. I should have took notes on how I did it last time, so I remember exactly how to put it in. Let's try again. So do I see anything here? No. Could not open device. Programmer initialize film.
Okay. That's better, right?
That's better. Let me try if... Oh.
Oh, hey. I think you're gonna overwrite your .bin file. Oh, we're in a different directory anyway. Okay.
All right. Flash ROM can never write if the flash ROM isn't found automatically. No EEPROM flash found. Okay, that's interesting. I have my light, so should be working.
Does the connection seem pretty good? Like, do you need to maybe press down on it a little as you try to read it?
I may need to do that. Programmer initialize failed.
Okay.
So let's see. Maybe my little thing here, I'm doing it wrong, and that's possible. So I may have to check out real quick what I did last time. Okay, let's try it the other way around. I'm quite sure I had it, but I could be wrong.
Couldn't open device. Do you want to try reading it?
Right. So yeah, it's probably reversed right now.
Okay. Try changing the last 2 digits to the 3-2 again. Even if we don't get the whole firmware off it, it'd be neat to know if there's a difference in the driver, I guess. And reverse the connection on the port.
What do you mean reverse the connection on the port?
Take your clamp and turn it around. Oh, hey, you know what I'm remembering is that with your little clamp, there's a ribbon cable coming off it, right? And if I recall correctly, it was unclear whether that ribbon connector should be flipped or not, right?
The ribbon collector, as far as I can tell you, needs to be aligned with the dot.
Okay.
Right. Then after that, it's on the board that makes a difference, which is like
Exactly.
if I take it off, you're going to see it here, what I'm talking about, right?
So there's two junctions that we need to check if it's upside down. That's all I'm saying.
Yep. So
that's 3 actually, given that. Yeah.
So that's the one that we need to kind of verify, make sure that it's good to go. But at the end, we should be able to get it done.
Yeah, that's so there's three junctions here, right? The clamp itself on the board. There's the ribbon cable going into the socket adapter, and then there's the socket adapter plugging into the socket reader, right? So 3 junctions that all could be upside down.
Potentially, but I don't think this one here with the board because I didn't move it. It's only from the other part that I took it off, and I should have taken notes. Programmer failed to initialize. So when I take it off, the light stops. Maybe I should just go take a look at what I did. See, those things, like if you don't do them enough, it's easy enough to forget about them. Yeah, let me go take a look real quick.
I'm gonna sound like a broken record right now, but if it were me, I would be getting out my label maker or a piece of masking tape or something and actually labeling that wire and saying, you know, plug this one into top left corner. And just like being kind to 4-way handshake in the future.
Maybe that's what I should do. Yeah, maybe that's what I should do exactly to make it worth it, or work it. I mean, so
if it's already come up twice in like 2 weeks, then yeah, let's fix it forever.
No, last time I was I checked it out. This one here, I thought I had it. I should have checked it out before starting the stream. But last time it worked out quite good, and we didn't have any issues. So if I go here on my screen, and now we just basically, I'm going to go on YouTube right away before we go a little bit further. Go on stream over here, take a look at that. Okay, that's interesting. I'm getting all these things. We have to go to the Mavic security. Oh, I should have put Mavic security. I thought it was going to autocomplete. We are going to take a look at the last live video that we had. And we should be able to, firmware, should be able to go take a look at exactly what I've done.
Okay. Is it the last one? I think it was 2 videos ago that we actually got the firmware.
You think?
Yeah, I think so. Because we pulled the firmware and then I went out to try to virtualize it, right? And then we,
Oh, yeah.
I think it was 2 videos ago.
Yeah, probably right.
Cool.
Okay, so 3.1 probably, right? So 2, 3, and then 3.1.
Okay.
Firmware extraction. So no, it was part 4.
Okay.
See,
Okay.
part says firmware extraction. See, plug it in.
Okay. Now, right there, we have red wire on which side?
Okay. We were doing the analysis here. Did we do? Okay, so the analysis was a little bit further. See, we had everything extracted here.
Mm-hmm.
So we're not too far away. Did I show it? That's what I'm interested in. Okay, let me go back. Sorry, guys. We're trying to find exactly the way that we connected. And that's exactly sometimes these things that if you don't do it enough, you forget. I'm quite sure I have it in the right way. Maybe it's the firmware we don't have correctly. Again, it comes down to, fortunately, mistakes happens, or not mistakes, but maybe equipment that we don't have. It's unfortunately, maybe this one is not going to be as, this video is not going to be as good as the others.
So another little tip that I could give to the audience is that whenever I'm taking something apart that I actually intend to put together again, I take a lot of photos as I'm taking it apart, because sometimes you don't think to write down everything, but so many times that has saved me, right? Where I'll go to put something together and be like, oh crap, where was this connected? Where was this wire supposed to go? And then I can go back and reference that photo that I took at a nice high resolution and zoom in on right exactly that junction and be like, oh yeah, okay, it was that wire. Maybe you could do the same thing for when you get this socket thing hooked up, the firmware extraction socket. You could just snap a photo and
I'd remember it
we can include
afterwards.
that in a blog post or something, somewhere that we're going to remember to check.
Yeah. Well, you know what? We know that the other time it worked with the other ones.
Yep,
So
that's right.
I have the board. I'm just gonna give it a try real quick.
Sounds good.
So we know that it works with the other guy, for sure.
And we're lucky that we did a stream, right, and kind of immortalize this process up on YouTube. But somebody doing a similar job just in their own home might not have that same luxury. So taking photos, leaving notes for yourself is super important.
And I need to get better at it. All right. And this one was 32B. Okay. Back in the USB.
Okay.
Very good. Just going to turn it around. Get disconnected. Need to make sure that there's not too much pressure onto that ribbon cable, because
okay.
You can recall it seems to be unplugging itself super easily.
I see.
Oh, okay. There we go. Now I'm seeing stuff that just happened. So we may have it right. I need to wait until it loads, because I'm seeing lights.
Okay.
We move around. See?
Oh, now I see what you've been up to this whole time.
Yeah, that's what I was saying.
Sure.
Like, I mean, those lights last time you didn't see them. But now you can see, right? So I'm quite sure it was 32 here.
Yeah.
Oh, there we go.
Yeah, it was
So now we can read it.
32B. Yeah.
So I removed the B, and for some reason it worked afterwards, right? So
Okay,
we know
cool.
for sure that this is the way to make it work.
Okay, so take a photo.
Yes.
And make sure that we can see the way that it's hooked up to the
Yep.
socket as well, because that's
Yeah.
another, like I was saying, there's 3 junctions here that could all be backwards.
There we go. All right, so we should be good to go.
Okay, cool. And just for my sake, the red wire is hooked up to pin 1, it looks like, right? If you were to
Yeah,
remove
where
that
the dot
thing,
is. Exactly.
good.
Right. So you can see
That's
here, I was
consistent.
able to get the flash to read. So then now I'm going to remove it. And as I remove it, you're going to see here on top, the light is going to stop, right?
Okay.
Bang. So
Makes sense.
we should be able to power on basically the device just by doing this. Is it the
Maybe.
preferable way to get everything done? No, because obviously it could alter some of the stuff there. I'm
And
just going to
a
make
lot
it
of USB ports, I mean, with a USB port, it only needs to be able to sync 500 milliamps, which we know is not sufficient to power the device. Not even close.
Yeah. So the dot should be on that side. We have everything sorted out.
Red on the dot. Yeah.
Is there any lights?
I
don't see any lights, any
I don't think
indicator.
there are any lights on the board, though. So that's fine.
So if I leave it like that for just the sake of it. Okay. So, it needs to be 64.
I am seeing something that looks like a button, though, next to the SD card
Oh,
slot. What's that? Is it a button?
that's a button. Yes. Talking about
Weird.
that.
Wonder what that's about.
I don't know.
That's
I
yeah, it's really weird. So this is not a button that was exposed on the chassis, right? So if I had to guess, there is some important function to that button, and it might be. Look, I've dealt with chips before where you need to press some kind of reset button as you're forming the serial connection, and then release it before the serial port will actually open or be accessible.
Oh,
So that's another thing to mess around with.
yeah.
While we're messing around with things, that's try pressing and holding that button while you clip the thing onto the serial port. Could matter.
Okay. Give me a second. I'm just gonna do a real quick Google search and trying to see if I can get. Oh, I guess I could do it here. Let's see. We have the ENQH, and then I'm just gonna go on Google here real quick. We are going to take this. It's XMC, and then can we just paste this there? XMC support. Can we see data sheet maybe?
I'm looking at the data sheet right now.
Is that possible?
I'll
It's
paste it into Discord for you, and here it is on YouTube. And again, just to recap, data sheets, even if they're from 2 different companies, as long as it's for the same part, they should describe the same thing.
Yeah, because they're basically doing the same thing. That's what made me.
They're all. It's multiple manufacturers working off of the same chip specification. It's one of the beautiful things about electronics fabrication is that it's almost perfect competition between manufacturers.
So is it possible it's XM? I'll give it a try with XM.
XM, the manufacturer, right?
Yep.
Yeah, totally.
And
That's what I was just saying.
There we go.
It's the EN25QH part that's important.
I should have shown. We got it.
Ah, yeah. Okay, wait.
Yeah, we found a way to get it done. And
All right, man.
I got the C as well.
Interesting, interesting.
That's what this one here is. 3V. Do we have the schematic of this one, this chip? Okay, so
Yeah, cool.
That's the one. That's the same one as.
Do you see package code 8HR?
This one?
Yep. So usually that'll be the last digit of the part number as you're reading the chip.
Interesting. I put C in there.
Well, it might be the
and on top it says
right
C.
after the Q, right?
Oh, okay.
I'm just saying often it's the last digit.
Yeah, but, so we're on page 9. If we go here, H, so that would make sense.
Yeah. You never know.
Yeah. Okay, good. I mean, we were able to move ahead and do something. That's great. All right. Yeah. If you give me a second, I'm just going to basically put it back to me. I am going to take this flash and put it directly on Discord so people can actually take a look at it. And that's cool. So there's nothing specific on this one that I don't want anyone to see because I never plugged it in onto my my own stuff. So we should be good to go at that point. I'm getting Discord to start right now. And then let's go to live learning. There is a topic as well that I put in. I don't know if you realize, Four-Way.
Yeah, I saw that.
Yeah, so that. I'm going to put that firmware right in there.
Yep.
So it's going to be directly into, oh, that's 8 megs. I didn't realize that.
That's great. I mean, that's totally consistent with what we pulled off the router. It's probably the same operating system.
Oh, hold on.
The same OS image.
Yeah. TP. Yeah. So I should have put camera in there. Let me just delete that message real quick and just put camera in there so it looks like it's the actual camera, not the router. Because otherwise we're going to have two of the same name. Rename. TP-Link. Camera.
Okay.
How do they call that again? The C200, I think, huh?
Yeah, C200. Tapo C200.
Oh yeah, I should probably put Tapo as well.
Whatever.
Well, to make
it's in the forum title.
Yeah. Oh, true. Yeah. Okay, so let's do that. Press enter. It's in. It's in there.
Cool. So
well, we got the you have that data sheet there, but that one didn't work, right? Maybe I should put the one I found.
What do you mean? It's the same chip. What didn't work about that?
The actual number. You remember? So
yeah. Okay.
EN25QH64 didn't work. I had to use this one here.
C, right?
Yeah.
Yeah, that's fine.
Okay.
I bet if you're to compare the two data sheets, it is exactly the same thing.
Yeah, probably the same. It's just for some reason it does not read. Okay, so I can bring it back over here. Because the thing is, if we do, let's say again.
Yeah. Okay. Great. I like it.
Because if I do this here, EN, is it going to work? So. Yeah, so with EN, we were having issues. So it seems that there is a difference in between the two that my device is not able to read.
Okay.
All right, that's good. All right, let's just take a look real quick, do a quick extraction. Then that's going to be the end of our video, I think, in this case for our live stream. Unfortunately, we failed at one thing, but we succeeded at the other. Okay, so we're going to open up a terminal over here. We're going to do LSLA just to take a look at it real quick. We can do a bin walk onto it, onto the TP-Link. We're going to take a look at what's in there. Oh my God, there's lots of compressed data. We have, I should probably make it a little bit bigger. Is it going to? No, it does not want to. So I have to view, edit, Control plus. I thought I did that, Control plus. For some reason, it's not working at all. All right, zoom in, Okay. So we have the Squash FS system, little Indian. We have some compressed data. We discussed last time that that's probably the part of the memory that it was found, right?
Yeah, that's the beginning of the memory.
Yeah, where it found it. JFS. What is above? I'm not too sure what that would be. The compressed data there.
Well, I mean, we can find out.
Right? Yeah. So I think
it's running off XZ, so it's a regular compression. It 100% will be picked up by binwalk.
So you said capital M and E, right? Last time?
Yeah, just remember to remember me.
Binwalk me. All right, let's give it a try and see what we're going to get out of this.
Cool. All right, yeah, we're going. We're decompressing. I'm actually surprised it's taking this long. It's only 8 megabytes or something. How big was the bin file?
The bin file?
Yeah.
8 meg, I believe. Quite sure.
Oh, okay.
Yeah. I'm quite sure that was.
Oh, one more files failed to extract. So
maybe
this
the M?
binwalk is really good about, yeah, exactly. The M is causing it to recursively extract. So why don't you just kill this? And then just only give it the dash little E. And that way we try only and make, yeah, get rid of that directory too. Sounds good.
Yeah. TP-Link, not this one. I need to put the /.
Oh, careful.
There you go. That should be it, right? Oh, it says .extracted, .bin .extracted.
.extracted. Why isn't the completion working? Oh, okay, I see. Oh, that's confusing.
Tapo firmware extracted .bin .x extracted. It should. Does not even autocomplete. Oh, it's
it has an underscore at the beginning.
Yeah, I just realized it afterwards. It's underscore. All right. There we go.
Cool. So now just do it without the capital M, and we'll get only the first level of extraction that way.
And then if we need to go a little bit further, we can, I guess.
Yeah, let's run it all the way till it ends. I'm sure it's mostly done. There it is. So what I was saying was binwalk is really good about telling you when it can't do something right. So we see the extractor.execute failed to run external extractor Jefferson-D JFS. So it's having trouble with that JFS2 portion of it, right?
Yeah.
It will often tell you exactly the tool you need to install.
Yeah,
if we're going to do a little bit of searching, it's possible we just need like an extra plugin or to install some little program onto this Kali machine that'll allow us to extract that.
Yeah, and we're going to do that another time. That's for sure.
Yeah, sounds good, man. Yeah. When I was doing that, the virtual version of the router firmware, that was something that I needed to do. So I couldn't even extract the Squash FS without going and grabbing another tool. So it is what it is.
All right, good. So what's interesting is I'm looking at the screen of what's being pushed, and for some reason it's not the same. Let me see real quick if I can adjust that as we are moving forward, and that takes too long. I'm just going to go through and then we can readjust this afterwards. So we got the laptop, we got this one.
Oh, is it getting cut off a little?
Yeah.
Okay.
I want to be able to not scale. I want to be able to mirror display. There you go. Okay. All right. That's much better.
That'll do it.
Keep this configuration. So for some reason it did not do that. It decided to upgrade it. All right.
Upgrade.
Yeah, exactly. Cool. So my device there that does the capture is 1080p, and then that's the reason why I was taking it. But this one is like 720 68p or something like that. So not a brand new laptop, which is fine for what we're doing. Okay, so let's go into underscore TP-Link real quick. Take a look at what we have over here. We have a bunch of 7Z stuff. Probably this here is exactly what we just discussed about.
And all these XZ files and 7-zip files are what we were recursively extracting before. So it makes sense that it was taking so long.
Yeah. All right, let's go to the.
But we have our squash FS root, which is
we're gonna go there. Take a look at what.
Again? That's the main event.
Yeah. Take a look at what we know for now, and then see auto detector sensor, and see if we can find something real quick. Then after that, we are going to be done. Oh, sensor.
So what I'm seeing right now is detect I2C. Could you pull that up again?
Yeah, I'm going back real quick.
Yeah, cool. So detect I2C install sensor, and it's a shell script. So we just read that shell script. I2C, for anyone that's not familiar, is another chip-to-chip communication method. Okay, so just like we saw SPI on the last board that we used, I2C is another way that you can have chip communication on a board and still address which chip is talking to which. I2C is a little different because let's back up. So with SPI, you talk to a certain chip by raising voltage on a certain wire that goes to that chip. And it says, hey, I'm talking to you. And then you'll spit the message out, it'll reply. And then you'll lower the voltage on the chip select pin.
Oh, I pressed on the wrong
With
one.
I2C, it works a little differently. It's it works by talking to a specific hardware address. So instead of using a chip select pin and selecting a chip electrically, I2C works by saying, I'm going to talk to you by your address. So it's a lot more like an Ethernet frame at that point. Hopefully that makes sense.
Yep.
What's really cool here is that we just identified a different method of communication that might be flying across this board, and one that we could definitely read using TTL. Kind of cool.
There's lots of stuff we can discover about this machine, or about what this one does. I mean, like, maybe not everything. There's lots of things in there that we have no idea what they do, but obviously, Cat.
What's that? UHTTPD cert and key. So it's probably an HTTPS interface that we're looking at.
Yep.
That's wild.
The RSA private key.
Yeah.
Copy selection, cat, and then paste this here. Are we going to see anything here? Maybe that's all the configurations. AC. Real quick, I don't see anything that interesting.
Not yet. What about under OSD? Because that would be where it's connecting to the camera, right?
Couple of bins over here. If I do, let's say
logos though.
Yeah, it's a logo. It's probably not going to work. Yeah. There's 5 cats.
Anyway, man, maybe we should leave this for part 2, because we kind of just got to a pretty interesting thing.
Yeah. Give me once. I want 2 more minutes.
He's in too deep.
I'm going to tell you, I'm not going to touch the system, and I'd be lying right after the stream. I'm probably going to look around and see if there's like anything I can find out of that.
Is Cal real?
Say again?
Is Cal real?
And the thing is, like, anybody that's that watches stream, that follow along and all that stuff, make sure that you join Discord, right? Discord has should probably change over here. Discord has pretty much everything that we are actually working on, and then the firmware that we just extracted on that device is going to be readily available over there. So if you want just to have fun with it, and then keep taking a look at it. That's a way to be able to do that. There's other ways as well, but obviously, like if you don't have the money to be able to get all those devices and then get everything all together, it's a way to be able to get you at least sorted out from an extracted tool, right, point of view. So that's good. I mean, let me 2 minutes here, and then after that, we're gonna call it.
Well, okay, hold up. Right on the screen, we see an RTL 8188. Do
Yeah.
we know what that is?
Nope.
It's a Wi-Fi chip.
Oh.
Yes. That's a big deal because we might be able to see a little bit more about how it, connects to the network and stuff by checking out the configuration for that chip.
Okay, so maybe that's something we can take a look, trying to decipher, but we could probably also put it on ChatGPT and take a look at what it does.
Yeah,
and if there's any issues
totally.
with it.
That's the great thing about finding such a common part number is that we can just toss it into ChatGPT and probably get a good explanation of it.
Yeah, understanding how it works and so on, because it's quite hard to. I mean, like if you're not a coder, it's quite hard to be able to understand everything that's happening here. But you're right. It says like the WLAN manager driver is not ready. Wait.
Yep.
Driver ready. EEPROM ready. So I mean, it kind of give us a little of an idea of what is going to be happening eventually. Do we have anything here? We have the other one, which is one operate. But we have the WQ 9000.
I don't know what that one. What's that?
That's the WLAN. That's what it says. Operate. Whoop.
Okay.
I wanted to not the operate, but the W. No, hold on. So underscore is cal. There we go. That's the one I was looking for. Sometimes it's possible that we could also find actual password. That could be interesting. But so far we didn't find anything.
Huh.
Okay. So if we do this, we go, can we do a, let's say a grep IR and then do root? No. Are we able to find, let's say admin? Because that's admin that we found before. Change admin password, do. Are we able to find anything? PASSWD. No.
Well, is there? Yeah, okay.
So maybe we're not going to find much over here at this point right now. But it's a good thing to think about. Was that?
Just go right into Etsy and see what's in there. But yeah, maybe we should play with this later.
Yeah.
You can tell how excited we are, right?
Yeah. That's good. That's very cool to be able to actually do this and then be able to move forward. So I'm just going to unplug that device there, move that laptop a little bit over. So yeah, it was great to try something else for a second time. Obviously, we were working with the TP-Link router initially, but now we have a camera which is completely different. And there's something we discovered out of that is we don't have all the tools to be able to get it done. I mean, it looks like it was feasible, but I mean, like without opening it up, it was hard to be able to find this out.
Yeah, once we opened it up, it looked like at best a maybe.
And the other thing too is, let's say some people could say, well, you could have soldered a cable on it, but then between you and I, what are the chances that I'm going to bridge some of those legs there? It's quite high, I think.
There's zero chance of success of soldering to those the pins off that QFP chip. No.
Yeah, exactly. So at the end of the day, there's not much we can do to be able to get that UART chip, but obviously, or not UART chip, but UART shell. So what we're gonna do is, I mean, like this one's gonna be on the side project for now. As soon as I get all the right tools to be able to get it done. So we think that the probes are one of the tools that we need, like good probes, because obviously the one that we use are not exactly good enough. These guys are good, but not exactly for this. And then the next thing that we need as well on top of that is most likely a microscope. So this one's probably going to take a little bit longer because a microscope, I think the one I looked at that was decent enough, I think is like $300-400. And then those probes are about $200 to $300. So That's another big chunk of money to be able to spend on that. So doing hardware hacking is not necessarily cheap if we are getting up to a little device like this one.
Maybe, yeah.
Yeah. So what are your thoughts on that, four-way?
I think there's always a trade-off between how much time you spend on something and how much money you put into it. So the devices that we just talked about, that would probably solve this problem for us. With the tools that you might have in your garage, you could build your own for sure.
Mm-hmm.
Little micro probes to attach to this, and if you had a saw or something, a thing to hold the board, and et cetera, et cetera. But it's going to take you a few hours at
Yeah.
least to
Yeah.
build something like that. Um,
What
you could
about
make good adjustments for it using wing nuts or something like that, but like, or you could just buy the thing. So it's all about how do you, I don't want to say how do you value your time, but like, is it worth it to you to have this tool that you're going to use maybe once or twice? I don't know. Only you can answer at the end of the day.
But I'd like to be able to figure out a way to do it without paying the big bucks.
Yeah,
So
definitely.
what I'm thinking about is probably trying to take a look if I can do it with needles, like have probes with needles, because the needles are quite long, and then they were conductors as well,
Hmm.
and super small. So I might be able to get a good and decent connection with it, and trying to figure out a way with those little hands there to be able to get it there. Because the thing is, those hands, it's hard to be able to apply pressure, right? But if you just like lift it up a little bit and you keep pushing on that needle there, you might be able to set it down exactly where it needs to. And then this one should potentially be able to resist it with a little bit of weight, like you mentioned before.
Yeah.
So I think that's going to be a project I'm going to be working on. And then once I got it running, up and running, I'm going to probably disclose this so people can actually potentially replicate this. Is it the best way to do that? Probably not. You're going to see four-way. It's like, but at the same time, we're learning. So, and if we can go with like something that's going to be within our household to be able to get it done, I think it's even better at that point.
Yeah.
Um,
I'm gonna have a bit of a think to see if would you be interested in building some probes?
some
Because it
pros,
might
sure.
not be that hard, and we might end up spending less time building something that'll solve the problem for us
Mhm.
than messing around with something that only kind of half solves the problem.
For sure, for sure. You have any ideas in mind? You don't have to share them right now, but you have an idea in mind. I'm assuming you're an engineer by heart, I guess, right?
Yeah, yes, definitely. I have some ideas, and I love that you have needles on hand because that's
Look,
gonna help a
I'm
lot.
ex-military. You
Yeah,
need needles. You need to be able
yeah,
to sew your stuff back up and all that stuff. And they also issue to military members, like every military member is a sewing kit. So if
yep.
something happened, you need to be able to bring it back up all together. And I used to be in the cadets as well before, so that's another
Mhm,
thing too. You needed to sew your ranks on your jacket. That was the only way to be able to put them there. So yeah, I didn't have a choice but to learn how to actually do that. So let's give it a try and see what we can build with this. Um, I'm not too sure how it's going to look like. Hope you're going to be proud of me.
I we'll talk offline. I have
Yeah,
some ideas.
that's good. I like that.
Okay. Cool,
All
man.
right. Well, it was great to be able to do the stream and be able to educate people, learn a few mistakes, few errors, or a few things that
Mhm.
we need to work on. And hopefully we're getting next week do something even better. Well, I mean
Yes.
that was already good. So
It was good.
yeah,
We got the firmware.
yeah,
Be
exactly.
happy. Yeah.
Great. Perfect. All right, sounds good. So thank you very much, Forward, for being here, and then all the information, the important information you share with us. And then hopefully we can do this again next week on Monday.
Sounds great, man. See you
All right.
then.
See ya.
Bye,
Cheers.
everyone.